Okay. What I want to do first is review, what I want to do first is calibrate my board. And then I'm going to have you look at some equations. Okay, we're going to do some pre-calculus first here. Okay, so write down these two equations. And I'm going to give you, I think 60 seconds would be enough time. Maybe 90 seconds would be enough time for you and your neighbor to work through these two problems. Ready, go. Talk about it with your neighbor.
And then school. So you had to get this balance out. And then we do the whole thing.
Hello. Thank you.
Okay, so it would be E to the negative 7. E to negative 17.
Okay, so let's refresh our memory here. If we have an exponential equation, the exponential piece needs to be by itself. Before we can rewrite base E, log base E of 8/12 equals 3x minus 2. Yeah? You agree?
Yes.
Okay. So you can punch natural log of 8/12 in your calculator. Then what would you do?
Add 2.
Add 2. And divide by 3. Okay? Not super worried about what the answer is. But I need you to know that that's what the process would be. Okay? On the flip side, what would you do over here?
Isolate the natural log.
Isolate the natural log. So if we subtract
What?
third.
Oh, 13.
We would subtract 13. Are we okay with that?
Yeah.
I thought that was like
Yeah, same.
Oh.
Like it was 12 and then 13?
Yeah.
Divide by the negative, and then since our base is E, we have E to the negative 4th equals X. Okay, so that was a good refresher. All right. Let's talk about a couple of properties. What do we know about E to the X and natural log of X? What is their relationship? They're inverses of each other. Therefore, if you compose two inverses with each other, they undo each other and you are left with X. So the natural log of E to the X reduces down to X. And E raised to the natural log of X reduces down to X. Okay? I know that you know those properties, but I want to reiterate them because they could be helpful. Okay, everyone get out their calculator. Okay, we're gonna have some fun here. E to the x. Oh. That would help. Okay. Let's graph e to the x. Yes.
So I don't know what's going on.
Okay, so we have e to the x. Okay? I want you to hit the trace. I can't even. There's trace. And f of 0, it gives you right away. What's f of 0? Okay? Let's find f of 1 as well. We're going to have some fun. So f of 1, that means all you have to do, if you are tracing, hit 1 and then enter. Okay? What about f of 2?
What is that the thing?
What?
Like hitting a number and then hitting enter and getting the Y value.
You've always been able to do that on trace.
I never did
I
that.
didn't know that.
Yeah.
That would have been a very useful thing to know for all
Yeah,
the
very
ACTs.
useful.
I'm
Lots of things.
fairly certain that I mentioned it last year, whether you were listening or not. If I didn't, I apologize. Okay, now, here is something else that you didn't know was a thing, CJ. If you go to the calculate menu, you know how we can find like minimum and maximum and intersect? We've done that. Well, do you see how there's also a dy dx? Right? So let's find the derivative at 0. dy dx is?
1.0000.
Okay, our calculator approximates. It's 1. Okay? If we press second calculate, we want the derivative, so choose derivative at 1. Huh. Using that feature, find me the derivative at 2. Yeah. Second trace. What is it, Eli?
It's 7.389.
That is incredible. What do you think will happen at f of 3 and f prime of 3? Try it. What happens? Okay, are you ready? The easiest rule you will ever have to know. The derivative of e to the x is e to the x. Right? Isn't that so fun? Right? Yeah.
Why is it really?
I was hoping you would ask that, Eric Watson. You do not need this proof, but Eric Watson specifically asked for it. I was going to do it anyway. All right. Okay, let's use our knowledge of our logarithmic differentiation. Okay. Well, what happens to natural log of e to the x?
It becomes x.
So now let's do our derivative. Derivative of natural log of y is 1 over y dy dx. Derivative of x,
1.
dy dx is
Oh.
y, which is
E to the x.
yeah. Okay, now keep in mind, however, that if we have something inside, whoops, that's not what I wanted to do. If we have something inside of our function, we will have to apply the chain rule. So if we have e to a function, then our derivative is e to the function times the derivative of what's inside. Okay? So I like to call this like the copy-paste derivative. If you have e to the x, copy-paste, your derivative is e to the x. Okay? If it's e to a function, copy-paste, then apply the chain rule. Okay? So, we're going to do some examples, and then we will look at exponential functions that aren't base e. Okay? Sometimes I like to be creative. Okay. E to the 2x. Okay. We had like laughter and like a 30-second lull and then laughter. It's all right. All right. So the derivative of e to the 2x. Copy paste. Times what's the derivative of the inside? Done. Bruno, do you have a question?
No.
Okay. Next example. Our derivative. Copy paste. Times the derivative of the inside. Now, do you want to use a quotient rule here? No, we need to think of 2 over x as 2x to the negative 1. Okay? So, when we take its derivative, if this is the same thing as 2x to the negative 1, then we're going to have negative 2x to the negative 2. Okay? You can leave it or rewrite it, but make sure, I would just be in the habit of putting that chain rule in parentheses, okay? That e to the power has to be multiplied by the entire derivative. If you don't put those parentheses, it's going to look like e to the negative 2x minus 2x to the negative 2, and that's not your answer. So make sure you put those parentheses so I know that you're multiplying.
What's the negative 2?
Well, since this is 2 times x to the negative first, when we do the power rule, the negative 1 comes out in front. Okay. All right, next example. we have here? We have a product. Very good. You need to be able to recognize that. So we need to use the product rule. The derivative of the first function is 1, and then we have our second function, plus our first function times the derivative of our second. Okay? So if we have e to the x squared, its derivative, copy paste, times the derivative of the inside. Okay? If it were me, I would rewrite this to be e to the x squared plus 2x squared e to the x squared. Okay? Yes, it's possible to factor out an e to the x squared. I don't expect you to. That's something that we may have to do, however, in Unit 3. Like if we had to set this derivative equal to 0, we would have to factor the e to the x squared out. But for your answer, I would not expect you to do that. Okay. All right. Let's try another one. Okay, so I'm going to color code things again, and why would I want to color code things for you? It is a chain rule inside of a product rule. So we have function 1 times function 2. Okay, so we have a product rule where both of them are going to need the chain rule. Okay, so our derivative, dy dx. Okay, so the derivative of the first function, since it is e to the 9x, our derivative is e to the 9x times 9. Okay, our second function stays the same, and then plus our first function times the derivative of the second function. All right? So we have cosine of x to the 4th. What is the derivative of cosine? Negative sine. So we have negative sine. The inside stays as is. And then we're going to multiply by the derivative of the inside, which is 4x cubed. Okay. I always like, if there's like a negative, I like to rewrite it so that it becomes like subtraction instead of like multiplying by a random negative value. So I would want to rewrite it as 9e to the 9x cosine of x to the 4th minus, I like the polynomial piece to be in front. That's how I would rewrite it. That's how I would organize it. Now, it doesn't matter, but that is just probably how you would see it, like in a multiple choice situation, or like in my answer key, this is how I would organize it. Okay, I am going to give you a problem for you to do. You're going to write it down, you're going to do it, and then when I say check with your neighbor, you're going to check with your neighbor. All right? So here is your example. Okay, check in with your neighbor. All right, Trevor, what'd you get?
There's going to be a 4x plus 1 times e x squared plus x.
This is Trevor's answer. Do you agree?
Yeah.
Thank you, Trevor, for putting 4x plus 1 in parentheses. Okay, if you don't do that, then the e to the x isn't being multiplied to both. So make sure you do that.
Nope, if we distributed it.
Yeah, sure. Yep. All right. So now, what happens if I give you like a 5 to the x, and I ask you for the derivative, or 8 to the x, or 15 to the x? Okay, how do you take a derivative of an exponential that is not base e? Okay. So don't write this down yet. I'm going to go through kind of how it works, like kind of the proof before I show you the rule. Okay. So do you agree that a to the x is the same thing as e to the natural log of a times x? Because e to the natural log would cancel out. And this, well, okay, since x is being multiplied, see how that works? Okay. Sorry, Fred. Okay, so we're in agreement that those two are equal in a kind of a crazy way. So, for me to show you the derivative of a to the x, what I'm going to show you is the derivative of e to the natural log of a times x, because I've shown you that those are equivalent, and we know how to take the derivative of e to a power, right? So e to a power is copy-paste times the derivative of the inside. Well, the natural log of a is like the coefficient for x. Like if we had 5x, the derivative would be 5. So the derivative of natural log of a times x is natural log of a. Okay? Well, we already know that this right here is the same thing as a to the x. Okay? So what we have for our derivative rule, and this is what you can write down, is that, I'll write it in bright red for you, the derivative of a to the x is, I'll write it like this, the natural log of a times a to the x. So you still have that copy-paste, but we're multiplying by the natural log of the base. Write down the red. This is your second rule. We've learned 2 rules today. E to the x derivative, and now a to the x derivative. Okay. I don't know how I'm talking so slow today, but we'll go over your blue worksheets on Monday or Tuesday during our review day. But you are not going to leave without me giving you your quizzes back, so you can work on those over the weekend. Okay. All right. Let's do a couple examples. Okay. So the derivative of 3 to the x. You are still going to do your copy-paste because it's an exponent derivative, but since it's not base e, you have to multiply by the natural log of the base. Kind of similar to our logarithm rule, right? Okay. Okay. Y equals 3 to the 3x. So our derivative, we have an exponential equation. So copy paste, the base is not e, so we'll have to multiply in the natural log of the base. But we have a function inside. What is inside? 3x is inside, so we'll have to multiply by its derivative, 3. Okay, one more. We'll do the top one, the derivative of 8 to the sine of x. Since it's an exponential, our derivative is copy-paste, but it's not base e, so we have to multiply by the natural log of the base. Then we're going to multiply by cosine x, because that's the derivative of the inside. Okay? Now, I want to sort through a couple things here. Okay? We have a lot of rules, and I want you to just notice a couple things. Okay. E to the x, what is that derivative? E to the x. Three to the x, what's that derivative? 3 to the x, natural log of 3. Careful. X to the e. What rule would we have to use here? The power rule. Okay? Bring down the exponent decreases by 1. Okay? Now, typically, we have rational values there, but that's not like a rule that they have to be rational. That's just typically what we see. Okay, here's what I'll do. I'll leave you with this. How would we find the derivative of x to the x power? I'm not going to go through it, but what we'll do is we'll start class on Tuesday with that derivative, because I think it's a really cool one. It's not, like it's a challenging one, but we don't have a rule to follow, right? This is not x to a number, and it's also not a number raised to the power of x. So we cannot use either one of these rules right here. All right? Okay, so I'll show you that one on Tuesday, okay? What I need you to do is obviously your homework, but I would also like for you to take your 2 quizzes, and since you have 2 extra days in your weekend, use some of your extra time to go through your mistakes on the quiz and redo those problems, okay? We have a test in 2 weeks, and we only have 3 tests in this semester. So that test grade is going to be very important, all right?
So this will be good.
Yes.
Will there still be a class recording on Tuesday for that?
Probably not. But maybe I will take a picture of, I'll post something, whether it be a video or a picture of the key. Does that make sense?
No, she said we had one already.